never let you down. I'ma shine on sight. Keep your mind on the grind and off of mine's alright. Right hard, I'ma ball on them squares. I floated $250,000 cars everywhere I go. I know in the lead they may see me like me, but no matter what they doing, they don't do it like me. Like a G, I hold it down for the town I'm at. In a flash like that, recognize I'm back. Strike a
Hey guys, Mr. Shaw here. We're going to be talking about graphing quadratic functions today. So again, we talked about this a little bit when we were looking at graphing lines, and today we're really just graphing any regular functions and all, and we are going to get a lot more in depth to it today. So let's get to it. First of all, let's talk about some things you should already know. So here's your vocabulary. Again, you know that quadratic functions and linear functions, again, a quadratic is just going to be x squared. Linear function is just like y equals mx plus b. The vertex, again, you guys know that that's like the highest or lowest point. So again, like for example, here's your parabola. It would be like right here at the bottom. Axis of symmetry is that same thing. Okay, so again, I'll point it up here. Okay, again, it would be just whatever line cuts it in half. Okay, it makes it symmetrical. The maximum and minimum, again, you see like here, like for maximum, it'd be like the highest point on a parabola facing down. Minimum, lowest point when it's facing up. And you guys know that a parabola is just the U shape that it makes. All right, and that's pretty much it. Now, again, like I said, it looks like we're gonna go a lot more in depth to it. So again, I don't want you to think that it's just gonna be like all the same stuff, because we're gonna do a lot more with it. So. In this case, we're going to talk about them when they're in standard form. We usually we're dealing with vertex form. So anyway, quadratic functions are always in the form f of x equals ax squared plus bx plus c, where a cannot equal 0. And then we know that the graph of a quadratic is a parabola. Okay, you guys don't need to write that down if you remember it. Okay. Then from here, again, the vertex, guys. Again, if you know this, don't write it. Again, you know the vertex, like I just said, is either the highest point or the lowest point on the parabola. And then, of course, axis of symmetry, okay, is the line that passes through the vertex and divides the graph into two congruent halves. Okay, again, you see here it just cuts it right down the middle. And then again, since the axis of symmetry is always a vertical line, it is always going to be x equals c, whatever that c value is, where c is the x value of the vertex. So again, if you see, like if I had, let's say that my vertex was at 2, 3, so then I would go to 2, 3, okay, and it was facing up, for whatever reason. Here's my parabola, and then here's my axis of symmetry. Okay, and then again, the axis of symmetry is going to be at x equals 2, which is just the x value of the vertex, all right, which we already knew. All right, so again, you see here, again, this is just one example of a parabola. Again, you guys don't need to write this. I'm just kind of giving you, running through the gamut with you. So again, we know that there's nothing inside with the x, so the x value would be 0, and then the y value would be -5. And then the axis of symmetry is always the x value of the vertex, so x is equal to 0, and you see here that it cuts it straight in half, okay, right down the middle there, and then the vertex is 0, -5, like I just said. All right. Now, here's what you really want to start writing down, okay? So now, again, we know that when it's in this form, in order to find the equation for the axis of symmetry and the x value of the vertex is this guy right here. All right, so now this is going to be the equation that we use to find the x value of the vertex now. So again, for those of you who are familiar with the quadratic formula, again, you see that this is just the first part. Don't write this down. Again, it's just you see that this would be like if I added on the radical to it, so b squared minus 4ac. This is called the discriminant. We'll talk more about it. But again, this is just like that. In order to find the x value of the vertex, you just take this first part of the quadratic formula. Okay. Again, that might be confusing, so don't write that part down. Okay. But again, that's all. That is just where it's derived from. All right. So let's keep going. And I just said that again. Don't write this part down. Okay, it gives us the x value of the vertex. We just talked about that. And then, but to find the y value of the vertex, because remember the vertex is always x comma y, you're going to use the formula x equals negative b over 2a, and then plug the x value back into the equation, okay, to find the y value. So let's say that, for example, it was my equation was f of x equals, I don't know, let's just do an easy one, x squared. Let's just do x squared. So then I found my negative b over 2a. Again, you see b here is, there's no b, so it's 0, and a is 1. So it would be x equals negative 0 over 2 times 1. 0 divided by anything is just 0. So then I would plug it back in. So I would need to find f of 0. 0 squared is 0. So f of 0 is 0. So my vertex is 0, comma 0. And again, we'll do a lot more examples. I just wanted to kind of give you a brief overview of what we're going to do. So let's go ahead and let's get into an example here. So again, I'm going to start by identifying what my a, b, and c are. So again, here a is 3, b is 6, and c is negative 5. Now be careful, because whatever sign is in front of it, that's the one you're going to use. So we're going to start first with the axis of symmetry. So again, remember x equals negative b over 2a. So let's find it. So x is going to equal negative b, so 6, negative 6 over 2 times 3. 2 times 3 is 6, so negative 6 over 6. So x equals negative 1. So my axis of symmetry is x equals negative 1. Now the other part about that we just found is the x value of the vertex, and I can go ahead and fill that in. So negative 1 here. Now in order to find the y value, we're going to have to take this negative 1, okay, substitute it in for these x's up here, okay, and go from there. So let's do it. So f of negative 1 is going to equal 3 times negative 1 squared plus 6 times negative 1 minus 5. So negative 1 squared is positive 1, and so 3 times positive 1 is just 3. 6 times negative 1 is negative 6 minus 5. 3 minus 6 is negative 3 minus 5, so f of negative 1 is negative 8. So my vertex here is going to be negative 1 comma negative 8. All right, now let's not write any of this stuff yet, okay? I just want you to kind of read this. So again, once you have the vertex and the axis of symmetry, again, now we can find the other points, and it says by making a table here. Again, that is what we would usually use, but we know that we have the tools of 1a and 3a. Okay, so again, with 1a and 3a, we can find the rest of the points on the parabola pretty easily just by doing that. And again, if you wanted to make a table to make sure, you can. But again, we already know it's symmetrical, and we know that we can use 1a and 3a. Okay, so again, that's why I didn't want you to write it down, just because again, it might be kind of confusing sometimes. So again, let's go ahead and let's graph it. So we're going to graph that exact same one. Again, it looks different, but I've already just filled in our information here. So I'm going to go to our vertex, which is negative 1 comma negative 8. Okay, and I know that my axis of symmetry is here, so I'm gonna fill in the axis of symmetry later. So again, my 1a, a in this case is 3. So 1 times 3 is 3. And then 3a is 9. So again, you always go over 1, okay, and then up however many this tells you. So you go over 1 up 1, 2, 3. And then over 1 and then up 3 the other way. And then over 1 up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can fill it in on the other side as well. So right here. So here is our parabola. It's a very skinny parabola. Whoops, that was terrible. I gotta redo that. Let's try again. There we go. Not so bad. Alright, and there you go. That's all there is to it. Again, you see that this one is just good. This one went up by 1a, and this one went up 3a. Okay, so 3a in this case was 9, 1a in this case was 3. And that's all there is to it. Alright, so let's keep going. This is, again, just another example. So let's start with, let me go back to the other one real fast, because I didn't fill in the axis of symmetry. Again, if I asked you to do that, it would be just a dotted line straight down the middle of the parabola. Okay, got that off my conscience. All right, let's keep going. So in this case, again, I'm going to identify a, b, and c. So a is negative 1. I'll just write it up here. So A is negative 1, B is 2, and C is 3. So again, let's start with negative b over 2a. So x, define the x as symmetry. So x equals negative 2 over 2 times negative 1. So negative 2 over negative 2. So the axis of symmetry is going to equal positive 1 this time. And I know that the x value of the vertex is also 1. And now we can keep going. So let's go ahead. I'm going to plug 1 back in. I'll just do it down here to find the y value of the vertex. So I need to find f of 1 to find the y value. So it'll be negative 1 squared. Again, be careful with how you write that. Plus 2 times 1 plus 3. So 1 squared is 1, and then you make it negative, so it's going to be negative 1 plus 2 plus 3. Negative 1 plus 2 is 1. 1 plus 3 is 4. So f of 1 equals 4. So the vertex will be at 4, 1. Now, we know that because of the negative, it's going to be facing down. All right, and again, because we've done these a little bit before. So again, we know that in this case, so let me go ahead and plot the vertex. So it's going to be 1, 4. And then we'll do the 1a and 3a. So 1a, 3a. Again, in this case, a is negative 1, so 1a is going to be negative 1, and 3a is going to be negative 3. So we're always going to go over 1, and then down. In this case, we're going to go down 1. Okay, and then over 1 and down 3. And then the same on the other side. Over 1 and down 3. So here's my parabola. Alright, now it also asks us for the y-intercept. Again, and you see in this case it is at 3. So I'll go ahead and fill that in as 0, 3. And one thing I want to point out to you is that we could have found that just by plugging in 0. If we plugged in 0 in the original function, 0 squared is 0, negative 0 is still 0, so that would have canceled out. And 2 times 0 is 0. So 3, it basically gives us our y-intercept right away. Again, whatever the last number it is, whatever that c value is, that's always going to be the y-intercept. So let me write that above it just so you guys can have something like that down. Okay, so the y-intercept is always going to be whatever c value there is there. All right, so now again, you guys already know this, I believe, for the most part. So don't write anything down like this. So again, you notice in this case that, like I said, this is our first one. A was 3, B was 6, C was negative 5, A was negative 1, B was 2, C was 3. So again, you see, we know that again, if A is going to be negative, that means that it opens down, and that's all there is to it. Okay, so again, we've already talked about that a little bit, so I just kind of wanted to breeze over this one. And then if you guys want to write this down, it is probably pretty good to write down the minimum and maximum stuff. Okay, that is really good. But again, you guys should know that for the most part. All right, and now let's go ahead and we're just going to determine whether it's a minimum or maximum just from the actual graph itself. So in this case, this is going to, like for letter A, this one's going to be facing up. Okay, so in this case, it's going to be a minimum value. Okay, this one right here is A is negative, so it's going to be facing down. Okay, which means that the vertex will be a maximum value. And be careful here, this one's actually backwards. Okay, so if I switched it all around, it would be negative x squared minus 4x plus 3, which in this case you can see now that it's negative, so again facing down, therefore that the vertex is going to be a maximum. Okay, I'm kind of running out of time here, so let me go ahead and finish up in the next video. See you then.